Okay. So, good morning, Dr. Jaiganesh, and good morning to the participants who are watching this live session. So, welcome everyone to our session on Big Data Analytics intro to Hadoop framework. So, today we embark on an exciting journey into the realm of big data, a field that has revolutionized how organizations process, analyze, and leverage vast amounts of information. In this session, we will explore the fundamental concepts of big data analytics and delve into the Hadoop framework, which has become a cornerstone technology for managing and analyzing big data efficiently. The increasing volume, variety, and velocity of data generated in today's digital age is necessitated robust tools and frameworks to handle such complexity. And Hadoop, an open source framework developed by the Apache Software Foundation, and provides a scalable and distributed computing environment that enables the processing of large data sets across clusters of computers. Its core components, including the Hadoop distributed file system and the map reduced programming model, offer powerful solutions for data storage, processing, and analysis. And throughout this session, we will cover the basics of Hadoop, including its architecture and key features and the role it plays in big data ecosystems. We will also discuss the real world applications and case studies that illustrate how Hadoop is used to solve the complex data challenges across various industries. By the end of the session, you will have a solid understanding of how Hadoop can be leveraged to unlock the potential of big data and drive informed decision making in your organization. So before we start Dr. Jaiganesh's session, I would like to give some short introduction about him. So we are honored to introduce Dr. M. Jaiganesh, a distinguished professional whose career in information technology and computer science spans over 2 decades. And currently, Dr. Jaiganesh serves as a professor at the Department of Information Technology at Karpagam College of Engineering in Coimbatore, a role he has held since June 2022. His extensive academic journey includes significant contributions at Jain University, Bangalore, and CVR College of Engineering, Hyderabad, as well as a notable tenure at PSA College of Engineering and Technology in Tindukal, where he transitioned from assistant professor to associate professor over 11 years. And Dr. Jaiganesh began his career as a lecturer and assistant professor at Christian College of Engineering and Technology in Tindukal, marking the start of remarkable trajectory in academia and research. So, Dr. Jaiganesh's academic credentials are impressive and reflect his dedication to the field. He holds a PhD in computer science and engineering from Anna University, Chennai, where his thesis earned the highest grade of highly commended. And additionally, he possesses an ME in computer science and engineering from the same institution and a BE in electrical and electronics engineering from Madurai Kamaraj University. His commitment to education and mentorship is demonstrated through his involvement in national initiatives such as the Smart India Hackathon and the CSIR Summer Research Training Program. Furthermore, he has coordinated significant events like the Smart India Hackathon and CIENCAA is a 2K19 symposium and showcasing his leadership and organization skills. So beyond academia, Dr. Jaiganesh has been recognized for his innovative research and contributions to the field of technology. He has received the accolades such as People Award from the Madurai District Tiny and Small Scale Industries Association for his work on GSM based traffic control systems and Best Paper Awards as in the esteemed conferences. His expertise encompasses cloud computing, big data analytics, and machine learning areas in which he has guided numerous PhD students and made international presentations. Dr. Jaiganesh also holds innovation patents from both the Australian government and IP Australia and Indian innovation patents. So underscoring his commitment to advancing technological research and development. So before the session, I would like to introduce our services at Tech Solutions. We are pioneering Sugi's venture. Our company is dedicated to developing innovative engineering and management and scientific tech solutions. It's tailored to support your ecosystem with our forward-thinking approach. So we pride ourselves on offering affordable services and robust support and backed by a professional and skilled team ready to deliver exceptional business plans. And Temstic Solutions specialize in a comprehensive array of services, including digital marketing, web designing, server management, and on-field marketing, and Android and iOS app development, and telecommunications, AI tools, SEO, and web analytics. We also excel in business operations and industrial process automation across and various sectors such as industrial research, so mechanical and automobile, aerospace and defense and electronics and energy, and architecture and civil engineering, so medical applications, maritime and marine, agriculture and textile and manufacturing, and more and more. So additionally, we are passionate about the this educational through the Mastering Up. It's a free platform aimed at unlocking skills for a brighter future. We invite you to join us in empowering young learners by sharing your knowledge and expertise. So our guest lectures are foster skill development, knowledge sharing, and personal growth, offering a platform to inspire and educate and connect with an enthusiastic audience eager to learn. So at the end, I would like to introduce to the motto of Dr. Jaiganesh: innovate, educate, and inspire. So I would like to hand over the session to Dr. Jaiganesh, and also thanks a lot for joining us today. And over to you, sir.
Thank you very much, ma'am. I
Yes.
thought I'm audible.
Yeah, yes, sir.
So
Yeah.
first of all, I would like to thank that Mastering Up. They will give a chance to me to showcase and explore my knowledge to the technical and the scientific community. So I personally I thank Suganti ma'am has requested me through LinkedIn. Thank you, ma'am, for giving me this opportunity.
Yeah, with my pleasure, sir.
So let's we will go to the topic. Can I
Yeah,
share my PPT, ma'am?
yeah, sure, sure.
Visible, ma'am?
Yeah, yes, sir. You can share. Yeah.
So, a very good morning to Nandal person here. I'm Dr. M. Jaiganesh, professor in Kappam College of Engineering, Coimbatore. So, I'm having 20 years of teaching experience. And as per ma'am introduction, you people are known about how I am able to traveling with this academic field, tie up with some industry also. So whenever I start my agenda, so these are the agenda today. This last next 1 hour, we will look into that. So why people are go for that, title is big data analytics. I just give a basic introduction about Hadoop because usually my lecture will give you the layman approach. Okay, people are not aware of, say for example, people are whether it will be a technical person or not technical person, even the people are able to understand what is big data analytics and why we people are going to Hadoop. So I just read up this agenda, read up big data analytics, introduction to Hadoop, and what are the fundamental Hadoop ecosystem. It's nothing but the Hadoop architecture and why people are moving to Hadoop. We have a distributed file system, DFS is there, and the network file system is there. Then why we go for Hadoop distributed file system? And exactly how the way that Hadoop distributed file system will be working. We come with one scenario to explain. And what about the architecture of Hadoop distributed file system, and what is the difference between Hadoop version 1 and version 2? And what are the advantages of Hadoop distributed file system? So why people are moving to these big data analytics? So this is a survey. Day to day, we are able to every month we are able to take over the survey. So the idea about that from as per April 2024, the people are having that the total population is 6.10, and unique mobile phone user it will be 5.65 million. You imagine that. And then individual internet usage is also 5.44 billion. And then social media and user identity people, they are using 5.07 billion. The total population, we crossed around half of the populations. So people are using mobile phone, internet, as well as social media. Then you people are imagining how much data to be generated. Okay, so this is also one of the very important thing once we enter into the big data. And then the same Jan 2024 perspective on internet usage. Okay, so individual using the internet use will be 5.45 billion. Individual using the internet, the World Bank, the purpose of bank only they are using. Individual using internet, CAA World as well as Facebook they are using, and individual using the internet for their workstations. Okay, and then statistical data analytics. So these are the last two slides you people are able to aware of that. In what way the data are moving. Okay, and then we people are imagine how many data are generated day by day. Okay. So when we talking about only financial industries, there will be a 25% of big data analytics using for the financial services only. Okay. So there will be 7 to 10 billion spent annually on technology for each four largest universal banks. So these are the things why people are able to going for big data analytics. And then apart from that, whether the big data is used for other applications like weather forecast, and then with the help of machine learning as well as artificial intelligence techniques. So these are the techniques, those are using for learning techniques. But how to manage, how to store, and how to handle. Okay, so these huge amount of data. So that is the very threat in the world nowadays. And then, so how does big data help here? So big data, say for example, when we talk about the application of weather forecasting, so how big data is helping here? So big data allows us to gather massive amount of data, such as from previous reports, climate change details, and wind direction, and precipitation, and so on. And based on this, we all the
Sorry,
data is
sir. Sorry for the interruption. Just make a full screen, sir. We can't able to see the words.
no, it will be okay, ma'am.
No, sir. You just make a full screen, like a presentation.
That's what I done that.
No, sir. We could not able. We can able to see the PPT only here. So just make a full screen. We can able to see the words also.
One second, ma'am. Now it will be okay, ma'am.
Sir, the bottom side you have some icons. No, the fourth icon. Just click that. The bottom of the some icons. Yeah,
Yeah,
the fourth.
that what I
Yeah,
done that. Even it will, now it will be okay.
yeah. Now okay, sir. Okay, sir. Yeah, okay.
Okay, ma'am.
Yeah, okay.
The slide is moving, ma'am.
Yeah.
Then, right.
Yeah.
So now I was in the slide of need of big data analytics, ma'am. Sugandhi, ma'am.
Yeah, yeah, yes, sir.
Then, ma'am.
Now have sixth slide only, right, sir?
No, ma'am. I was in ninth slide. Need of big data analytics. Yes, ma'am. Sixth slide only. Okay.
Yeah, okay, yeah, sure. Okay, sir.
No,
Yeah,
the title will be need of big data analytics.
yeah, correct. Yeah, sorry. Yeah, you can
Done.
start. Yeah.
Now it will be moving, ma'am. Next.
No, sir. Now also can able to see the sixth slide.
Now seventh slide. No,
No.
I will see, ma'am. I will do it.
Yeah, okay.
So what is that based on this last previous examples we have discussed the scenarios and all. So big data usually includes the data sets with sites beyond the ability of common used software tools to capture. Okay. Say for example, whether the big data means we have a huge number of data. These data are not processed by a normal or software tool. Okay. Say for example, it's a huge volume of data. Whether we have software tools, it will not able to capture, create, manage, process the data within the tolerate elapsed time. So this is the uh, definition about that big data. Okay, so when we talking about big data, as per ma'am introduction also, ma'am told that will be a three V's of that. So volume, velocity, and variety. Okay, so these are the three V's are related to our big data analytics. Okay, and then when we talking about these data, what are the data to be boiled down in big data? Say, for example, it including social data, missing data, and transactional data. And then the information will be around 40 gigabytes. This is an abnormal growth when we compare to 300 times from 2005. Okay. So then very important question will be that how to handle this data, and how where we are able to store this data, and how we access the data, and how we process the data, how we manage this stuff. So these are all the things of the difficulty when we go for that big data analytics, or otherwise the data is not properly processed by a common software tool. So that purpose only we will go for that big data analytics. So when we talk about introduction to Hadoop, introduction to Hadoop. So Hadoop is a software framework to run large data sets of a distributed application. Okay. So the founder of Hadoop is Doug Cutting. He is working in Apache software systems. Okay. So when we talking about Hadoop, it brings a collection of large cluster of commodity hardware. Okay. So when we talk about hardware, means it's nothing but a cheap hardware. We say it's a cheap hardware. Okay. So when we talking about big data analytics, so big data analytics is a we need to process a huge volume of data. So when we talk about Hadoop, Hadoop is nothing but a open source framework. Okay. Instead of it will able to process a big data analytics. Okay. It's able to process big data. It will perform an analytical operation. Okay. And you people are nowadays people are able to saying that big data Hadoop, big data Hadoop. Not like that. Okay. Big data is different. Hadoop is different. Okay. Hadoop is an open source software framework, but we have plenty of tools are available to process our big data. Even Google also having their own tool. IBM also having their own tool to do big data analytics. Okay, so people are able to understand, confuse big data is only Hadoop, not like that. So Apache, they developed the open source famous software framework that is called Hadoop. That's all. And then so why, say for example, people are able to do that? What is the need? How the way data is able to collect it? So evenly we noted some people are here that a Facebook founder also worried about many of the people are using Facebook as a day-to-day calendar. Say for example, early morning they get up early in the morning, they take one selfie and they upload it in the Facebook, and simply they say, I wake up. And then they, after that, they ready with the office, they take one selfie. I'm ready to go office like that. So, the individual human is able to generate these type of data means how the way Facebook data center maintenance and analyticals people, how to maintain these data. It's a big threat. Okay, it's a big question. So that purpose only we will go to that Hadoop framework. Okay. And then there we have a very good definition about given by Gartner. Gartner is a very famous computer scientist. Often he will deliver a lot of definition of recent and booming technology. If you find any technical term, we just go and type the definition of Gartner means he will deliver something. So as per I am the follower of Gartner, I will give this definition. So Hadoop is an open source software framework that supports the processing and the storage of extremely large data set in a distributing computing environment. So it's an open source software framework that processing and storage of extremely large data sets in a distributed computing environment. So all the modules in Hadoop are designed as a fundamental assumption. There will be a hardware failure or common occurrence would be automatically helped by the family. So once you people are able to ask, sir, when we go for that Hadoop, we need any higher system to install. It's not like that. Okay. So we need to install our Hadoop in a distributed mode in a regular PC. Okay, in a regular PC also, we just to install our Hadoop framework. Some slides are moving, ma'am. Subanti ma'am, sorry to interrupt.
Yeah, yes, sir. Yeah, no problem. Sir, I think you can take it now 10th slide, right? Introduction to Hadoop. Yeah, now moving to 11th slide.
Hadoop ecosystem.
Yeah, yes, correct. Sir. Yeah.
Now Hadoop ecosystem is visible.
Yeah, yes, sir.
Now,
Yeah, yes, sir.
yeah, right.
Yeah.
So when we're talking about Hadoop, it's a when we say as a ecosystem means, so we have plenty of tools available in that common architecture. Okay, I thought some of you people are known about that. Okay, so it's a complete framework. But when we go for the, it's my own. It's my own reference. Okay, say for example, it's my own model for Hadoop architecture. Okay. So when we say these Hadoop architecture, so it will be a four layers. Okay, Hadoop is having a four layers. So we start from the bottom layer. It's called a storage layer. Okay, we start from the bottom layer. It's a storage layer. So the storage layer consume Hadoop distributed file system. Okay, the storage layer consume distributed file system. And in that bottom first layer is divided into database also. So one is storage, another one is database. Okay. So here the database will be some of you examples. I thought you people are here. Some NoSQL database, HBase and column D. These are the two databases as per my example I put it in. We have plenty of MongoDB, Cassandra. So plenty of variety of tools are available. Okay. So here, as per my motto here is we need to segregate into these four layers. Then only, say for example, that Apache software systems and many of IBM Google, they launch plenty of tools for this big data analytics day to day. Okay, they launched many versions at that. So that what I just modeled these four layers, especially for this Hadoop. We need to accumulate into any layer. Okay, so that what my idea. This is my proposed system. So when we talk about, there will be a four layers. One is storage. It consumes database also. Then data processing. Then data access. Then data management applications. Like how our computer networks OSI 7 layers are there. So like that, we whether we I proposed these four layers. Okay. So any new tool will come. Say for example, it's a processing tool. We will accumulate into data processing layer. When the access tool will come, we will accommodate into data access layer. When any application, say like Zookeeper, Flum, or OZ will come, or any tool will come, we will accumulate into management. So these are the four layers. And when we talk about the bottom layer, the storage layer, it's a Hadoop distributed file system. I thought in this class, I will give you, in this session, I will give you a complete idea about how the way Hadoop distributed file system is working. Because it is the storage lake, okay, we will say, which is the storage lake of our big data is our Hadoop distributed file system. So when we move to the database, we have plenty of databases out there. Here I mentioned HBase and column DB. And when we stand alone, say what are the basic functionalities are available in big data? There will be two functionalities available. One is store, another one is process. Okay, so the storing is fully taken care by Hadoop distributed file system, and the processing is fully taken by MapReduce. I thought you people are aware of that. In that MapReduce only, we accumulate the data access and the data management application. Okay. So there will be two process when we talking about big data analytics. One is called the store and another one is called the process. So when we call the process, it's nothing but map reduce. It's one of the very important concept. And map reduce will be in Hadoop 1.0. When we're talking about the yarn, the abbreviation for yarn is yet another resource negotiator. Okay, it's like a cluster. When we explain HDFS, people are aware of that, how that yarn will play a vital role. And when we're talking about the access, PIG is a Latin access language. Okay, because when we're talking about big data analytics, I will give a definition about differentiate between it's a big data analytics. So database is a non-relational database. Okay, it's not a relational or traditional database. Okay, it's a non-relational database. So when we're talking about non-relational database, it's nothing but our NoSQL database. Okay. So it's not a query like no SQL language. So instead of we need to compensate, there will be a data flow or data accessing programming will be there. A query language will be there. These query language is called Hive as well as Pig. Okay. So Pig and Hive, they will be taken care by the data access. Okay. Say for example, in analytics, how the way the input will be given, how the way the output will be getting. So those part is taken care by our data access. And when we're talking about the data management application, it's a purely Zookeeper, from OZ. These are the things or the analytical management tools and monitoring tools and workflow tools. Okay, workflow tools. So, say for example, I will tell you on a simple example to explain these one scenario. I will explain these four levels. Okay. Say for example, whether you imagine I'm a bank, I'm able to running big data analytics, and why I'm able to running big data analytics in my bank. Okay. So when we're talking about my bank, I need to have my customer data. Okay. I need to have a customer data. So the data are customer data and my account numbers are stored in our storage layer. Okay. And then when we each customer is having their own database. Say for example, whether I am the customer, I need to withdraw money or I need to deposit money. So these informations are particularly stored in my own database. That is done by my DB. Well, so why we go for these big data analytics? Okay. So say for example, in a bank, whether I'm running a bank, so credit card section will be there, a loan section will be there, debit card section will be there. Okay. So every month they are able to generate report for the individual user. Say for example, there will be 1,000 users or 1,000 clients or 1,000 customers are in a bank. So you imagine 1,000 credit card transaction will be noted down. 1,000 debit card transaction will be noted down. 1,000 loan accounts will be noted down. So these three accounts will generate how much data. Okay, so based on the data only, we need to generate report. Okay, based on the data, we need to generate report. Okay, say for example, whether being I'm a Jaiganesh, I'm having loan account, I'm having debit card account, I'm having credit card account. Okay, so how whether I need to have a statement of loan statement, debit card statement, and credit card statement. Okay, so how we are able to process for a single user, or it is easy when we go for a n number of users. So that will be done by our map reduce. Okay, that will be done by our map reduce. That is called here processing. Okay, and then so next layer. So what is the data access? Say for example, I want to access. I want to need the some particular services. Say for example, we am a debit card holder. I need to access the UPI services. Okay, so UPI services I just request. So whether a single user I request means it will be okay. A n number of people are able to access. They are able to ask the services of UPI means. So it's a big question. So during that time, whether our data access will come into picture to help our data processing. Okay, and then how I am able to run that entire transaction execution monitoring. Okay, say for example, whether I'm a new user, I'm able to create my loan application. The loan application will be processed by my data management applications. Okay, and then say for example, whether I'm able to give a username, password, or whether I'm able to give any confidential information. So these are all things are followed by the data management applications. Okay. Or otherwise, I need to get any statement file download. So these are all done by our data management applications. Okay. So as per my scenario of simple bank example, people are aware of that how these four layers are able to work. And then, so next we will move to that. What is mean by distributed file system and why we go for HDFS. So when we are talking about distributed file system, it's a method storing accessing file based on client server architecture. Okay, it's a client server architecture. So we have talking about there will be one or more centralized servers are stored in the files. It can be authorized by proper authorized files. Any number of remotes can in the network. Okay. So, for example, DFS is network file system protocol that permits user to acquire file across the network. Okay, like how the way we people are. If you're talking about distributed file system, you people are it's a very complicated like that. You simply store a file in your mailing services. It is one of the example for our distributed file system. Or otherwise, in your server, you have maintained a server. You just store that data in a server, and you need to access that server with the help of your own mobile or with the help of any system or any local system that is called simple. So people are aware of that in when we are studying our operating system, when we run our operating Unix file systems, one of the example for our file server systems. And what are the limitations of NFS? The files reside on a single disk or a disk of network machine. And then another limitation is it does not provide any reliability guarantee to data stored in the machine. So NFS has overloaded problems. Overloaded problems are there, and many clients are accessed using the same distributed machine. So like that, these are the limitations. Okay. So based on this DFS and NFS, we move to Hadoop, Hadoop distributed file system. So when we're talking about Hadoop distributed file system, um, already I explained you. So Hadoop is a storage component of HDFS is a storage component of okay. It's the very first time it was developed by Google File System concept. It is a distributed file system. Okay. HDFS is specially designed for distributed file system. I give a definition. Based on the definition, I will explain you each pinpoint how HDFS will be. It's a specially designed distributed file system for storing huge data sets with a cluster of cheap computers or commodity hardware. It includes streaming data access patterns. Okay, I will explain you. So Hadoop is a specially designed distributed file system. Akka, I thought you people are able to understand. It is used for storing huge data sets with the cluster of cheap computers or commodity hardware. I will explain you. It includes streaming data access pattern. Okay. So whenever we want during the time, we will access the system. So that what it includes streaming data access patterns. It's an on-demand distributed file system. What are the key features of HDFS? So I already told you, when we're talking about Hadoop, we have a sophisticated computer, higher end system will be there. For instead of we need to install Hadoop, not like that. Okay. So we have our own laptop with a capacity of 1 TB hard disk and 8 GB RAM, we can able to install Hadoop in a distributed file system. So once we need to install that Hadoop, okay, uh, whether when we what are the features of HDFS? It splits a large file into a tiny pieces, a small pieces of files called blocks. It is a manageable size. Okay, so what is the motto of HDFS here? It will split large file into small pieces of files called it's called a blocks, the manageable size. The size of the block usually consists of 64 MB or 128. Okay. And immediately you are able to ask him, sir, what about the block size when we store our data in a normal computer or laptop? I come to explain you in our next slide. So, ma'am, the slide is okay. I mean, Hadoop distributed file system slide. The page
Yeah,
is
yes, sir. Yeah,
good.
yes.
Yes, ma'am.
Yeah.
So, when we usually a commodity computer is having single block size like 4 KB or 8 KB in the memory sector levels. Okay, so and then you people are aware of that. When we open a Word document, when we open a Word document, you just open that Word document and you save that Word document and you right click and you need to see the size of the Word document. Anyone tried? I don't know. It will be around 12 KB or 16 KB, like that. Okay. So, say for example, in a Word document, we keep on typing the text. Say for example, it will move to that one page to second page and third page and fourth page. Then it will be go around the 10 page. Once again, you save the document and open it and you just see the size. It will double the existing size. Previously, it will be 8 KB means now it will be 16 KB. Okay, now it will be 16 KB. But the entire Word document it consumes, it occupies all 16 KB means, okay, it will not occupy the full entire 16 KB. So this is the problem when we faced in our traditional computer system. Okay, so that what I just give a differentiate between what is the traditional file system and how the HDFS will play an important role. So the regular file system, the size of the block will be 4 or 8 KB. So when we talking about HDFS, once a computer is installed Hadoop framework means then the memory blocks will be automatically occupied. They segregated in terms of 64 MB. Okay, 64 MB. Okay, or 128 MB. And then, so these are the two examples. I will clearly explain you what is the traditional file system will do and what is the HDFS will do. Say for example, the document size is 12 KB. We stored block 1 8 KB and block 2 it's a 4 KB means here also there will be a 8 KB will be there. Remaining 4 KB are wasted. But when we talking about HDFS Hadoop distributed file system, we want to store the files of 100 MB means block 1 it will be 64 MB and block 2 it will be 36 MB but remaining 28 MB used for other file storage. So that what the definition I give. It's a cluster of commodity hardware. Okay. Hadoop distributed file system is nothing but a cluster of commodity hardware. Okay. Or otherwise cluster of a cheap hardware. So that what we just mentioned in the definition. I thought according to these two differentiation, you people are able to understand what is the file system and what is the Hadoop distributed file system. Here, the block one will be 8 KB. The block two will be automatically allocated 8 KB memory, but the remaining 4 KB will be wasted. So it's a static memory allocation. When we go for the dynamic in HDFS, okay, it will be whether the remaining 28 MB is manageable by other data storage. Okay, so that is the idea about the differentiation between a regular file system to HDFS. Well, so next we will go for the architecture of HDFS daemon architecture. Okay. So when we're talking about this architecture, there will be five important components are there when we're talking about Hadoop distributed file system. Actually, Hadoop distributed file architecture is working with the principle of master-slave logic. A master-slave logic. It is running with the basic functional elements called daemons. We see daemons. So daemons are the background process always running in HDFL file system. It's always live. Okay. So that's what we say is a daemon concept. So there are five major components, and then in that major component we categorized into these three are master, these two are slave. When we saw this slide, the name node, secondary name node, and job tracker is considered as a master node. And then when we're talking about slave nodes, data node and task tracker will be a slave nodes. And what are these five components? So how these five components will helping our Hadoop distributed file system to use it. The purpose is, what is our HDFS purpose? It's nothing but a huge data will be stored in a dynamic manner. Okay, in how dynamic manner it will be stored. Okay. And then one more point here we need to note down. The communication between this master to slave, okay, the communication between this master to slave will be there. So they are able to talking each other. So the idea it will be there will be a privilege they offer for the communication between among this master to slave or among these master nodes, among these slave nodes. So when we talk about master nodes, name node and the secondary name node, job tracker, these three will talk to these three people, okay, each other. Okay, so the name node will able to contact the secondary name node. The secondary name node will contact the job tracker. You know, and similar to when we talk about the slave nodes, there will be two slave nodes of there, data node and task tracker. So these two are able to discuss each other, so there will be no problem. But there will be a restriction they have given a master to slave communication. So when we talk about master to slave communication, a name node and secondary name node is able to talk to only data node. Okay. So the name node and secondary name node is only talking to data node. And job tracker is able to talking to task tracker. Job tracker is able to communicate to task tracker. So these are the privileges, communication privileges we will offer in our HDFS architecture. Next. So I'm able to explain you one cement factory scenario, how the way the HDFS will be working. Okay. So here I just imagine that cement bags are our data bags. Okay. I thought if people are aware of that, whether I come with one scenario to explain how the way exactly Hadoop distributed file system is working. Well, so in cement factory, the cement packed in bags, stored in warehouse. How they store? How they store? Every warehouse is having a storekeeper. The role of the storekeeper is storing and managing cement bags in an appropriate manner. You imagine there will be a warehouse will be there for a cement factory. Okay, so there will be a storekeeper is able to storing, managing all these cement bags. Say for example, cement will be in variety like 200 rupees cement bags, 250 rupees cement bags, and 300 rupees cement bags. He is keeping a register. Okay, say for example, a logbook or keeping a register. It implies where the cement bags are stored. Okay, say for example, in particular a space area, 200 rupees cement bags are stored. In another place, 250 rupees cement bags are stored. In another place, 300 rupees min max are stored. So register has the room details in the warehouse where the different variety of cement bags. The same type of cement bags are stored in which place. So like that, we are continuing our scenario. Well, so in some extent, what happened? The storekeeper lost the registers. Okay, somewhat he missed the register or he lost the register. Then how we are able to access the warehouse? It is very difficult to access the warehouse. The same reflect in our Hadoop distributed file system. It's called a name node. It's called name node. Okay. Once the name node cracked means we will not get where our data is stored in a data node. Okay. So that what I explained you. What does mean by a name node? Name node is nothing but it is a register. It's a considered as a metadata here. So metadata, you people are immediately you say one example. It's a data update. Yes. So name register is able to consume where our data is stored in our data node. Where say for example, we say A is equal to 10. So A is equal to 10. The A value will be stored in which data node? It will be aware of that our name node. Okay. So name node is the node which store the file system metadata, which file maps to the block location and which blocks are stored on the data node. And then, so where the data are stored, it will be managed. It's a login register. It will maintain all the details. So when we're talking about secondary name node, the only purpose of secondary name node is to perform periodic checkpoint. Okay. So we say it's a the name implies that it's a secondary name. Okay. Say for example, in some extent, a name node is crashed by anyone during the time the secondary name node will play an important role. Okay. And then, so what are the actions are done by our name node? Whether our secondary name node, it will be periodically take the snapshot actions of our name node, as well as it will able to maintain that the recovery process of all transaction done by our, it's a data backup. Secondary name node will done the data backup for our name node. Next. So when we're talking about job tracker, okay, job tracker is a master which creates and runs the job. Okay, so which are the jobs allocated by name node? Those jobs are run by our job tracker. And then job tracker which can run the name node allocates a job to task tracker. So once the name node will allocate jobs to job tracker will contact task tracker to complete the task. This is the routine job about job tracker. The primary function of job tracker is resource management. So managing the task trackers, tracking the resource availability, and task life cycle management, and tracking its process, fault tolerance, everything will be taken care by job tracker. And the next, data node. So the data node is the where actual data are resided. It's a storage, it's a memory. Data is nothing but it's a storage component. It's a memory to store. All data nodes are, and then here one more important thing is that so every data node will contact name node and they say, I'm aware of that, I'm available, I'm not dead, I'm live like that. So all data nodes send heartbeat message to name node for every 3 seconds to say that they are live. So name node does not receive heartbeat from a particular data node. Say for example, if a name node not receive any heartbeat from a particular data node for 10 minutes, then it consider the data node to be dead or out of service and initiates replication of blocks with where posted on the data node to be posted on some other data. So here one of the very important property of a data node here is a single data is resided in three different data nodes. It's a very important. Say for example, the A is equal to 10. That value is stored in data node 1 and data node 4 and data node 7. It's a very important. With this property only, the big data will been able to achieve the fault tolerance property. Okay. Say for example, a single data will be there means the data is stored in the three different data nodes. So the purpose is one data node is crashed, we get the data of A is equal to 10 from another data node. So these indexes are maintained where our A is equal to 10 will be stored in data node 1, data node 4 or data node 7. These indexes and tables are maintained by our name node. That's what we say name node is a metadata data. And come to the last component, task tracker. So task tracker is located from nodes independently managing their respective tasks. Each task tracker is responsible for independent implementation of the task specific while the task applicable for the allocation of task. It will run the task. So I will give you one simple example to explain you for a basic addition operation with the help of these all these five components. Okay. Everyone, please listen. You can able to follow these example means you need to understand that how the way these five components are working. So the first thing is when we say uh, name node, the addition of two numbers, this job is allocated by name node to a job tracker. Okay, allocated to name node to a job tracker. We need to perform a addition operation. We need to perform a addition operation. And the name node will give where the data are stored. Say for example, A plus B is equal to C means where the A will be resided in data node, where will be B will be resided in data node. This information also given by name node to job tracker. Then job tracker will find where the data node is having the particular addition operation operands A and B. Okay. Then job tracker will allocate an addition of A and B. The task is addition operation. It will be done by our task tracker. Okay. It will be done our task tracker. Which data node it resided, that task tracker will contact arithmetic logic unit and perform an addition operation. The output will be C. Okay, and the C will be stored in the data node itself, and it will be resided in another two places. Okay, another two places. That two places will be allocated by name node through job tracker. Say for example, A is equal to 5, B is equal to 10, then the answer 15 will be resided in C means C is equal to 10, it will be stored in which place. Data node 1 or data node 4 or data node 7 or data node 11 or data node 12. It will be informed by data name node. Then it will be stored. This index will be stored in our name node A. So this is the very simple example. I will explain you how the way a Hadoop distributed file system is working. And when we talking about what are the difference between Hadoop version 1.0 and 2.0? So it's about MapReduce concepts. Here, Hadoop 2 will able to support MapReduce, and many plenty of Apache frameworks are there, like Spark, Amma, Giraffe, MPI. So like that, lot of tools are there. So MapReduce both processing cluster resource management. Here in 2.0, they have introduced one resource negotiator, yet another negotiator. Okay. Say for example, when we start with the 1.0 version, the data storage will be 64 MB. When we work with the yarn architecture, the block size for Hadoop 2.0, it will be 128 MB. Okay, 128 MB. And then, the 4,000 nodes per cluster we can able to process with the help of Hadoop 1. When we talking about Hadoop 2, it will be 10,000 nodes per cluster also we can able. And here it will be work for slots. Here it will be work for containers. So based on the containers concept only, in cloud computing also they introduce the Docker concepts. So that is also one of the very fundamental platform for Docker is done by our Hadoop and big data analytics. Single name node to manage for entire. Here there will be a multiple name nodes as well as manage multiple namespaces. So these are the difference between Hadoop 1.0 and 2.0. And one more thing, here you people are able to observe that the storage component of it's nothing but our. I already told you, HDFS is a cheap hardware, or it will be a commodity hardware. Okay, so they make a normal cheap processor to make it as a grid or cluster like that. They will run that entire execution. So this is the idea of Hadoop distributed file system. The purpose of in this class for the introduction, I thought I will explain you why we go for big data analytics and what are the uh, layers are in our Hadoop. When we talking about, there will be 4 layers of there. And when we talk about the advantages, it's a fault resilience. It means a framework is able to, in one more word is there for fault resilience. It's nothing but it's a self healing. Okay, it's a self healing. So there will be any problem faced by a particular name node, a secondary name node will play a role. Okay, or otherwise, when we talking about Hadoop 2.0, so one plenty of name nodes are available. One name node will be crashed, then another name node will be taken at the in charge. Okay. Similar to the way, so the data availability. So data will be available in 3 places. So whenever a person is able to ask for a particular data, it will be able to give it. And data reliability. Okay, so once in one place the data is crashed, we will get from another place. That's what the reliability. And scalability, I already told you, we need to run 10,000 clusters, client clusters per server. And then the replication, data are replicated in 3 different places. So, and then we have a very good recovery backup also available with our HDFS. So I just give a brief review in that 1 hour time what I am able to cover. I cover. I thought you people are able to understand that what is big data and what are the layers of Hadoop, why people are going for big data, and in particularly how the way that Hadoop distributed file system is working, and what is the difference between a network file and distributed file system versus Hadoop distributed file system. I thought within this time I will conclude my session. Once again, I will able to thank Sugandhi ma'am and mastering of people. They give me this great opportunity for me. So thank you one and all. Do you have any queries? You can able to ask. Please.
Yeah, okay. Thank you, sir. Thank you so much for the wonderful presentation. I have some questions here. So, first one, how can we optimize the performance of a Hadoop cluster for handling petabyte scale data? And what are the best practices for ensuring the scalability in such environments?
Then when we talking about, so we have Apache Spark will be there. No? When we face with the problems like beta problems, Apache Spark, it's a very good tool. It will able to solve beta versions problems because man, that what I while I am explaining that layers day to day plenty of tools are available in the market. Yeah. Say for example, they launched many versions, many tools are launched. Okay. So I thought your Apache Spark will be a very good beta versions problem by big data will be solved by Apache Spark.
Okay. Sir, what are the key security challenges in Hadoop ecosystem, and how can we implement effective security measures to protect sensitive data in a Hadoop cluster?
Okay, this one. It's a very good question, ma'am. Because nowadays people are moving to big data analytics instead of security is a very big question when we talking about big data analytics because we need to store our sensitive data to the public environment. Say for example, I'm running a pharmaceutical industry. For the purpose of I'm having a huge volume of data for the analytical purpose only, I'm able to go for that. For analytical purpose only, I go for that big data. So during the time when I prefer Hadoop framework, okay. So the standalone, there will be a lot of security algorithms are available. Okay, when we talk about the frameworks, okay, we are able to launch many PGP based software, secure software algorithms are available. Okay, like we say um, RSA, and then public cryptography algorithms are available. Even any tool, especially for that Hadoop distributed file system or a big data analytics, it's a public cryptography algorithms are there. They embed it and they will serve a good idea about security purpose. Okay. Say for example, any eavesdropper will eavesdrop it. Say for example, I told you, the pharmaceutical company, I'm having a particular formula. If someone will enter into that, they will get the data means it's a big question. But with a lot of public cryptography algorithms are there, tools are there. With the help of we overcome that.
Okay, thank you, sir. Sir, what advanced data processing techniques such as machine learning and deep learning can be effectively implemented on Hadoop platform? And what are the key considerations for their deployment?
And once again, ma'am, please.
Yeah, so
The
what?
machine learning algorithms you are asking.
Yeah, yes, correct.
So actually, that was a very good question. I need to differentiate, ma'am, here whether when we're talking about AA is a big data, it's a big superset. Okay, A is a big superset. In that we have a subset is our machine learning. Okay, but we usually I make there will be a intersection of AI with big data analytics. We give a intersect with our big data analytics because for the purpose of huge data sets, we are not handled by a common software or we are not performing in analytics. So that purpose only we will go to big data. But here, learning algorithm is completely different. Okay. Say for example, whether the example I told you, the weather forecast. So the weather forecast previous data is learned by our learning algorithms. Okay, and then the learned data will be processed and it will be analyzed by big data. That is very important. Okay, so any type of deep learning algorithms, machine learning algorithm is able to generate plenty of data. But the idea it will be so how we are able to analytics the data. It's a very important. Okay. It is a different journal. It is a different journal. but we give a input to big data analytics. What we are learned data, we are given input to our big data analytics. That is the thing, because we will not able to correlate, or we are not related to big data analytics is particularly for machine learning, deep learning, not like that. It's not like that. And then I here it's a right time to explain you. So AI is a superset,
Okay.
ML is a subset, and deep learning is a subset of ML. Okay, so the center point will be a deep learning, and we put another round, it will be ML, and it will be a huge circle, it will be A. But I put a nearby intersect all these things. I put one more circle, means that is big data analytics. Okay,
Yeah.
it will able to apply A, will able to apply ML, it will able to apply deep learning based on our requirement.
Okay.
Thank you, ma'am.
Thank you, sir. Thank you so much. So this is my last question. So what are the advantages and challenges of deploying Hadoop in cloud environments such as like AWS EMR, Google Cloud, Databricks, or Azure HT Insight, and how do they compare with on-premises deployments?
Yes, ma'am. So it's a very good question, ma'am. So for example, we people are saying it's a relevant thing. Cloud computing and big data analytics means how the way we are able to, what are the challenges? Very first challenges is security.
Yeah.
Very first challenges when we go for cloud, because it is a public environment. Okay, first is security, and then scalability. Okay, scalability also a very important factor, because with the help, we need to adopt the cloud in big data. We assume that 1,000 customers will enter into cloud, but when we go for public environment, we don't know. Okay, the scalability of the user. Okay, sometimes it will be 10,000. Sometimes it will be 1 lakh people are able to enter into that cloud. Okay, so security as well as scalability is a big threat of when we adopt cloud computing in big data analytics.
Yeah, okay. Thank you, sir. Thank you so much
Thank you,
for
ma'am.
the useful answers. So the answers are very useful. I hope the access that the participants can understand about that. So finally, so ladies and gentlemen, as we conclude our insightful session on big data analytics intro to Hadoop framework. It's my distinct honor to extend our heartfelt gratitude to Dr. M. Jaiganesh for his invaluable contribution. Dr. Jaiganesh, your expertise and profound knowledge in the field of information technology and computer science have greatly enriched our understanding of Hadoop and its pivotal role in big data analytics. So we deeply appreciate the time and effort you have to invested in sharing your insights with us today. So your ability to demystify the complex concepts and present them in a comprehensible manner has not only educated but also inspired us to explore the further and apply these learnings in our respective field. So it illustrates the career and dedication to academic excellence, serves as a beacon of aspiring technologists and researchers. So thank you, Dr. Jaiganesh, for your enlightening presentation and for being with us today. We look forward to more opportunities to learn from your vast experience and to collaborate in future endeavors. So your contribution has made a significant impact on all of us, and we are truly grateful. So thank you once again, and we wish to continue success in your life, in your future endeavors also. And finally, sir, on behalf of we present, just wait, sir, just 1 minute. Okay. So, sir, on behalf of Mastering, and we present this virtual memento as a tribute to our guest speaker, Dr. Jay Ganesh. Your insightful contribution have enriched our knowledge and inspired us profoundly. This token of appreciation symbolizes our gratitude for your expertise and dedication. So, thank you for sharing your wisdom with us and shaping our understanding in profound ways, sir. So,
Thank
thank
you.
you, sir. Thank you so much.
Thank you, ma'am.
Yeah, thank you, sir. Thank you so much.
I leave the call now.